Donna is the F# PM. She's the same kind of person for F# that I am for C#. And before joining us relatively recently, she worked on the Scala team with Martin Odesky and others, and will tell us about F# and in particular information-rich programming. So I'm sure you'll tell us what that is too.
Yes, I will.
Okay, off you go.
All right. So today I'll be talking about F#, information-rich programming, which is the focus of the F# 3.0 release, which is included in Visual Studio 11, which right now is in beta, and so it'll be released sometime, probably this year, maybe, but it'll be soon. But right now you can download the beta, you can get the bits, you can try it out. It's really a good product, I would say. So just to give you an overview of what I'll be talking about, first I'll just briefly go over F# syntax in case you haven't seen it before. Then I'll talk about some real-world problems that we saw and how our language, the design of the language features in F# 3.0 were really motivated by these problems and how we chose to tackle them. And in particular, there's a feature called type providers, and I'll give you some demos about that. And I'll also tell you how they work under the hood, since this is an audience I think that will appreciate knowing more about how this actually works. And then I'll talk about a little bit about some future directions of F#. Where are we going next? So just to give you the F# tagline, kind of position the new features and our current features, we say that F# is a practical, functional-first programming language that lets you write simple code to solve complex problems. So this is really the main theme of the language. So anytime we want to design a new feature, we really care about the simplicity and conciseness and being able to express your algorithm in a very direct way. So to give you a very brief example of simplicity has to do with how concise F# is. And here is an obligatory example that compares F# to an imperative object-oriented programming language. So on the right, we have C#, and this is the familiar Ganga 4 command pattern. And if you see, there's a lot of boilerplate, right? There's only 2 lines of code that are actually doing anything, and that's the the execute functions, the implementations here for the break command and the turn left command. But yet, in order to understand what this code is doing, you have to read all of this. Now, fortunately, the command pattern is a very famous one. So you read it, you'll immediately know what it is because you've read Ganga 4. But there's a lot of patterns that are very specific to a project, or you tweak the pattern a little bit. And so because you can't express what you want so directly, it ends up making the code more verbose and basically harder to maintain and harder to read. So as you might expect, in F# we express this with higher order functions, and since F# has type inference, we don't have to write all the types everywhere. We just write it in the type definition of a command, which we say takes a rover, returns nothing. Unit is the same as void. And we just basically write the implementation of the things that actually matter. So basically, we distill out everything from the right-hand side that matters, and that's what you get in F#. Right. Okay, so let me show you some F# code in action. These are going to be some really simple examples, but just to give you a sense of what the syntax looks like. So in F#, one of the nice things is that you can write if you put an expression in brackets, that gives you a list. So that's what this open bracket here is doing. It's saying that create a list, and the elements should be looping from 0 to 25 inclusive, return a tuple that's I and it's square. And this show grid function is just something to display it in a UI. You can ignore these warnings. That has to do with 64-bit. All right, so this is just a very simple grid control that shows the results. Now, if we wanted to do something more interesting, we'd probably use the pipe operator. And what the pipe operator does is it lets you write the argument before the function. So here, this is saying, create a list of the elements from 0 to 25. Then take that, pass it to filter. So this is similar to like Unix piping, right? So you would have a command, the output of a command would become the input of another, and you kind of chain things together. And that's how code is often written in F#, partly because of type inference, because now list.filter knows exactly what type of list it's getting, which is integers. And then we'll map every element to its square, so we're filtering out the odd ones, squaring it, and then we're going to display the result. So, as you expect, the squares of the even numbers. And let's see here. And basically, just to show you more explicitly what the pipe operator does is if you write g of f of x, well, really you're applying f first, but you have to write g first in most programming languages. But in F#, you typically would write x, and then you'd pipe it to f, and then you'd pipe it to g. So it's very direct. You get to see things in the order that they're happening, which is usually very important in programming. All right, so that was very simple. And the thing with functional languages is sometimes people are like, well, okay, that's great. You can do stuff with lists. I sometimes do things with lists, but can I actually code anything I would do in real life? And the answer is yes, you can. And even more so now with F# 3.0. In fact, like I said, we design these features to really solve some real-world problems that have surfaced kind of in the last 5 to 10 years. And to motivate these features, I'll start out with 2 pretty uncontroversial propositions. 1, we live in an information society. So we like to think of it somehow as almost like a revolution, like the Industrial Revolution, changed things dramatically. And the internet obviously has changed things as well. But now with the internet becoming entrenched in our daily lives, it's like information is just everywhere, and it's so readily available. And there's social networking, there's freely available various sources of data. There's you can pay for data, which I'll show in a moment. So it's really actually changing the way we use computers, and it's changing the kinds of programs that we use. And the problem, though, is that our programming languages are information sparse. So when we use a general purpose programming language, it doesn't know anything about the domain of what we're operating on, generally speaking. So let's say I was going to write a program that was going to filter some a Twitter feed. Well, I have to create kind of this ontology of the program that I want to write. So I have to write a class for a tweet. I have to have a concept of a hashtag, an at tag, and all these things. I have to set this all up, and this happens with every domain that we use. Now with Twitter, in this particular example, it wouldn't be so bad because there aren't that many different interconnected types in that domain. But what if we have a database, or what if we have a web service, or what if we have some custom file format? It's very difficult typically to connect that up with your programming language because the programming language doesn't know anything about those sets of types usually. So we're saying that this is a really big problem. It's actually getting a lot worse because, as I said, the programming landscape is changing quite a bit. And when we are using statically typed languages, now let's just assume for the sake of argument that we want to use statically typed languages. So supposing that, there's this impedance mismatch. Basically, we have the schematized data, and we have our type system and our programming language, and the two are completely disconnected from each other. So what people end up usually doing, or it's very common, is to do some code generation. So basically, you would point a code generation tool at your database, and it would create a bunch of classes that represent each of the different tables in the database. Now, the problem is that it's kind of introducing this separate step in order to integrate that type system with yours. So that means that now you have to either run the code gen tool when you do a build, like say a nightly build, or you have to have the code generated artifacts around. And so that usually means putting them into source control, which then means that you have to make sure that you know that you don't edit those, and those are special. And you also have to make sure that when the schema changes, you run the code gen tool again. So it's not integrated. It's not the way when a class, when something you depend on, like a class you might depend on, changes, you recompile and you automatically, get things that depend on it will see those changes. And if there's errors, you'll see those errors, right? So this is kind of divorced from the standard way in which we build and write programs. And sometimes you can't even do code gen. You actually just use some API that gives you back, object, and then you have to figure out what type it is, and you do a downcast. Or sometimes you just get strings, and you parse out the strings, and you figure out there's like an integer in there, or there's a date in there, and it's just really awful. And so it's like, well, why are we even using a statically typed language in the first place? If our main task is to connect to these schematized data sources, then it really doesn't matter that we have types because we lost all the types. So what's nice, what the important thing to note though is that these schemas are types, right? They're just not the types our programming language knows about. And as I was saying, the programming landscape is changing. And so if you look at just over the past 5 years, the number of freely available web APIs has increased dramatically, and also more and more people are using them. Like back in 2000, probably not very many people were using the eBay web service, right? But now lots of people use the Facebook service and things like that. And they're also making tools that make it very easy to expose your data as a service. So I think, in the next few years, we're going to see even more of this. So it matters even more because you don't want to do code gen every single time or write a different type of code gen tool for a different protocol. And, it just gets more and more difficult to manage as time goes on. So we have a feature in F# 3.0 called type providers. And you can think of it as giving you IntelliSense for data. Now, IntelliSense is the term that we use for autocompletion in Visual Studio. So usually when you have a database, you don't get to give it the database file and press dot. Well, maybe in VB6. You get to give it the database file and press dot and say, oh, these are the tables in my database. That just doesn't happen, right? What you typically do presently, like say in C# is you run this code generator tool, point it at the database, generate a bunch of classes, and then you press dot and then it works. So there's that extra step. And it's only because there's a code gen tool that extra step even works. If there weren't one, then you'd be host. So let me give you an example of where this might come in handy. So Freebase is an open Creative Commons graph database. And it's big. It has 22 million entities. So you can think of it as like if Wikipedia had a schema and we're like a database and we're directly connected and you could connect up entities. That's what Freebase is. Now it's probably about the same quality, maybe not quite even as high as Wikipedia, but for our purposes, it's a very good example. Now, most databases that we're going to interact with, of course, are not that big and they're not that interconnected. But if we have a small device, we may not want to have the whole schema on our system. So in this graph here, you can see that you just take a few hops and you go from things like Gregory Peck to like UC Berkeley. And typically, most databases have schemas that are disjoint from each other, so you can usually close off a piece. But with web APIs, you see that things are more and more interconnected. So you can see that you couldn't possibly code gen Freebase. And in fact, you couldn't even code gen part of it without losing types because, like I said, it's very interconnected. So there's a domain within Freebase that's chemistry. So it has like chemical elements and things like that. Well, you might think, okay, well, I'll just code gen that part. That's the only part I care about. Well, it turns out that an element has the person who discovered it, which is a person, which connects back to the rest of the database. So now you have to cut it off somewhere, basically. So let me show you a demo of how this works. So in order to use a type provider, I basically reference a DLL. And this directive here is for scripts in F#, which basically let you run in a REPL, in an interactive window. And this is basically referencing a DLL, which is going to tell the compiler how to make types out of the schema that's in Freebase. So here I'll give a type abbreviation, which is the root of the Freebase data source. And that's like kind of where things start out. That's basically, kind of like the catalog in a database. So I can type web data dot, and it's taking a second. See, it took a second, not because my computer is slow, and not because F# is slow, but because it actually went to the Freebase web service, pulled down the schema, and is displaying it in the IntelliSense window. So basically, this is live against the Freebase data source. And you can see there's a ton of different domains. There's, business, celebrities, chemistry, exhibitions, fashion. And then if you click on each of these, it actually usually has, so it usually has a comment that tells you what that thing even is, right? And so with, like I was saying, the number of web APIs is increasing. So the chances that you will know a particular web API are very slim, right? So you want as much help as you can get when it comes to using these. So just for fun, I'm going to use the celebrities domain. And we can see there's a lot of really important information in here. So like, for instance, I might want to know what are the substances that any celebrity anywhere has ever used. And then when they use those, where do they go to rehab? And then there's interesting things in here. There's a super couple. I didn't know what a super couple was, but it's telling me, see, because it's giving me information. In my IntelliSense, it's giving me new information. It's saying a celebrity super couple, also known as a power couple or dynamic duo, is a popular or financially wealthy pairing that captivates and intrigues its observers beyond normal expectations. Okay, so this sounds pretty good. I'll pick that one. And I'll show it in a grid. And to run this, I basically right-click and say Execute in Interactive. And this will run it in the interactive window. So I don't even have to compile, although, of course, it's doing something, compiling in the background, kind of dynamically. And in a second, it'll bring up, I didn't do, that's what I didn't do. There we go. So this control is not that fancy. You have to actually display it before you. So you can see it's loading, and it's doing it asynchronously. And this grid is a very simple grid. It doesn't actually have any types in it. So this image, it is an image because that's the type of that field. And so you can see there's lots of really good data here, like Brangelina and Tomcat and Posh and Bex and, Bennifer, Michael and Marcy, and, it's good. Now, let's do something that, might be a little bit more interesting to this audience. So let's look at fictional universes. So this is going to, first off, if we hover over this domain, okay, see how much more data there, like what more of a tag there is? It kind of tells you about who's editing this data source, right? There's lots of it. Just really, really tells you what a fictional universe is. So it's basically, any universe that somebody has created and that works are set there, which could be a movie or book or whatever. So, and then you press dot, and it tells you, now it's really interesting how much stuff is in here. There's calendar system directionality, employers in fiction, fictional object destroyer, and the methods by which these fictional objects destroy things, fictional plants, medical conditions in fiction. Okay, so let's just look at, this is basically going to give us all the fictional universes. I'll just show the first 100 here. And let's just see what this data looks like. And there's also images here. The Buffyverse, Star Trek, Middle Earth, Earthsea. There's things I've never even heard of, like the Circle Universe. Does anyone know what that is? Battlestar Galactica, the Star Trek Expanded Universe. And so you can see it's this particular domain is very extensive. Now, let's say we wanted to do some queries against this. So if we click on if we go back here, we can see that there's all kinds of things like fictional universe creators, fictional character creators. So let's suppose we want to answer this question. Who has created the most popular fictional universe according to this highly reputable data source? So in other words, what are the who's created a fictional universe that had the most work set in it? Now, those works could have been written by other people as well. So like, say Star Trek was created by Gene Roddenberry, but a lot of other people wrote works for it, like books and movies and things like that. So in order to do this query, you can really see how the functional nature and the sequencing operation in F# are really useful here. So first, I'll get all of the fictional universe creators. And if I hover here, yeah, see, it tells me quite a bit about what a creator of a fictional universe is, if I didn't already know. And so here I'm going to map, which just basically means I'm going to transform a list into another list of the same length. I'm going to pull out, for each creator, I'm going to pull out the name. Then I'm going to iterate over the universes that that person has created, count the number of works, so collect up the works, calculate the length, and basically return a new list. So I want to show this result. Again, I will execute an interactive. There's also a keyboard shortcut, which I sometimes use. So here we can see that according to this database, not too surprising, George Lucas comes out really far ahead. J.K. Rowling is not that far ahead, but it looks like it might be accurate. So you can also write this query in a different way. If I can write something that looks very similar to C# link, for instance, where I can use select and sum by. And this is just kind of a different way of writing the query. It does exactly the same thing. So this really kind of points to one of the other advantages of type providers, because link is incredibly useful. But if you don't have a link provider for your data source, you're kind of stuck. So it works really well with databases and web APIs and things like that. But some custom type, there's nothing you can do. So basically, type providers kind of put link on steroids. All right. So I said F# is concise, but this is how much code you'd have to write, including manually defining the schema. And this is just to get a tiny part of the Freebase database. Now, this code is all inside of the type provider, so it's safely hidden away from the user. They don't have to deal with it. So basically, we can program against web scale schematized data. So really, this solution can scale very well, and we don't even have to wait for the code generation or for our code to compile. And this really points to how well this plays with the scripting nature of the F# interactive window. So basically, you get started right away. You don't have to set something up. You don't have to run some wizard. You don't have to read some web page that tells you, okay, this is how you even get started. And you get type checking, and you can detect schema change. So Freebase really schema changes very, very rarely, but a custom database schema might change, and you can set in the type provider when you create it how often you want to poll for changes to the schema, or if you want maybe the type provider to kind of maintain a connection and kind of invalidate the type checker. And there's in the type provider interface, the type provider can basically tell the type checker to throw things away and start over. And the advantage here is that now you get all this fantastic tool support. So suppose we wanted to connect to multiple data sources. Let's say we want to, connect to the Bing Maps API, which gives us driving directions, or Bing Search, Business Search, or Google Search, or whatever. Well, the way people do this right now is, so let me give you an example of the program I want to write. So suppose that I have a startup and I want to tell people what zip code to live in. And the way I'm going to do this is I'm going to get their age and their other relevant demographic information, figure out where they work, and tell them, what zip code is most similar to them in terms of who already lives there and how much money they make. So ordinarily, I would have to do a bunch of annoying things. So I could use the Bing SOAP services. And this is this big, long web page that tells me how to use this tool that's supposed to make things easier. And so I have to run this command line. And then it says, if you're developing your application, use this, set this member, do this other thing. And it's not easy. And this is, they've made it as easy as possible, right? But there's just a lot of details that you have to worry about as a programmer because you're code generating, so you have to care about that. And then there's just weird things. The name of this class and its constructor may be different depending on the tool you use to generate the client proxy classes. So the documentation is saying, don't trust this name. And then you get like weird things that happen. So it tells you that this returns a calculated location array, and then this here is telling you that it's actually a geocode location class. That's not really a type though, right? Because they haven't defined this type. It's a type that you're going to have in the future. So you kind of click through this, and it's just very, very strange. It's not a seamless experience. It's not code focused. Whereas with F# type providers, you get a completely different experience. So in order to get started, what I want to do is I want to get some census data. So I can go to the Windows Azure Marketplace, and this is not trying to be a plug for them. This is actually an interesting idea, I think. So you can basically buy data or get a trial version of something. And so there's a provider here who has all of the government census data. And there's a trial version available. And if you click on the details, it gives you a URL to use. Now this tells you how you actually connect. So it'll take me to another web page that's just as complicated as the one I just showed in the screenshots. And then it's going to tell me, okay, well, this is the schema, which is just great. I get text in a web page telling me the schema and telling you what the fields are named. Now, remember these names because we'll see them again. So the way I use this is I copy this URL, go to my F# code, so the way you're supposed to connect to this particular data source is to use an OData service type provider. So I just say, this is the service URI. So here it's saying, can't read schema. Oh, that error could be a little bit better. But all right, so I put in, and there was some squiggles, right, because these things didn't exist. So now it actually just retype checked everything, pulled down the schema. It's very fast because it's not pulling any data, just schema. And you can pull out like the root of the thing, and you can get the data context, which is very important for getting started with an OData service. And then here I'm just going to set the credentials, and then I can iterate over each element. And so let's say I want to filter out things that are just in a particular state, and I can I get IntelliSense here, and I know exactly what's available. So state name, and here we'll say, all right, so we'll filter on a state and a county, and then we can write here again is a list expression, and here I'm just going to pull out the fields, and in some cases I'm converting them from a nullable field into an actual decimal. Here I'm not doing anything very interesting, but in general, you can imagine you're pulling out data, you have to clean it, you have to, figure out what things are out of range. You may not be able to trust everything in there. And then I'll just sort by the city and then the zip code. Now, the next thing I need to do is I need to get the driving distance from each of these zip codes to where the person works, because that's one of the things that I asked for, of how far they want to drive. So in order to do that, I'm going to use Bing Maps, which had that documentation those really weird web pages for the SOAP service. But here I just have to, it's weird. Let me just try. I've actually not seen that error before. Oh, that's so weird because it just worked. Okay. Build. All right, now it's good. All right, so this is now you can see how uniform it is. Before I was connecting to an OData service. Now I'm using WSDL. They're two completely different protocols. If I did CodeGen, I'd have to do two different things. But here I just put in the same exact thing when I instantiate it, the URI to use. Here are just some type abbreviations. This code is a little bit more verbose because there's just a lot more types and they're kind of spread out. I'm not going to show you the details of the code, but just to show you how this helps you use a particular API. So I have a route, I have the route service, and I have a route request. And I want to know what to do I can do with it. So, for instance, this is showing me you have a route service. Well, you can calculate the route. You can do it asynchronously. You could say do it only for major roads. Now, when I get the result, well, what other things are there other than the distance? Well, there's the bounding rectangle of the whole area that you'd have to drive. There's the time in seconds, so you could figure out how long a drive you want to be in addition to the distance. So basically, this lets you explore an API in a really nice way, which IntelliSense, of course, already lets you do. But with these web APIs, you're just using so many different things. You have to, it really helps when you can get more information, basically. And just to show you how elegant F# is in terms of math, here's the very simple Euclidean distance, weighted Euclidean distance metric I'm using to calculate how close a given zip code is to a particular user. So this is just subtracting each component of a vector and multiplying by the weight, squaring, taking the square root. And in F#, you could write, just subtract x from y, the list, square each element of the list, and multiply by the weights, take the sum, square root. It's exactly the same. So here we can see that you can program against multiple data sources using type providers. You get to access everything with a really nice uniform interface. And as you can see, F# works really well for program logic because it's concise and declarative. So you probably want to know what's under the hood. Well, a type provider is a standard .NET assembly. There's a particular interface that I'll show you in a moment, and there's certain metadata attributes that you put on there. And it plugs into the compiler and the type checker, which also means it plugs into the IDE because those are built on top of the type checker. So the way it works is that the type checker gets an unknown identifier. It then asks the reference type providers if they know what to do with this identifier. So that could go to a web service, a database, a local file, anything. It could return a constant. Then it gives it back a system.type, which says basically what do you do with this? Excuse me. Here's a system.type, and when you call methods on this synthetic system.type, these are the actual pieces of code that need to be inserted into the program that use the type provider. So basically, like I was saying, this is the step here, step 3. Basically, the type provider is basically giving us back a piece of a program AST, which then gets merged into the main program by the type provider. And the interface looks like this. So this, for instance, gets the type corresponding to a particular name. This, for a particular method call, it tells you it returns what the body should be that should be inserted into the main program. This is invalidate, which the type provider can tell the type checker that the schema has changed and that everything needs to get refreshed and restarted. And this would get all of the types that are the root of that type provider. So there's 2 different ways that you could implement a type provider. You could use an erasure-based strategy, which is what Freebase does. It doesn't actually code-generate any types. Or you could just actually generate new types, which is what we do for the OData service and SQL and things like that. So it's up to the creator of the type provider. So you have a lot of flexibility. So in principle, even if you are generating types, you don't need to have unwanted references to external types. So let's say you're only using one small part of a database, and even if you co-generate that part, you don't have to do the rest of it. So it's sort of a plugin. It's extending the type checker in the compiler, but it's not an arbitrary, it's not a general compiler plugin. It can't do any kind, just a general kind of AST manipulation. You can't insert a phase into a pipeline. However, because it's not a general plugin, it changes type checking in a way in which the IDE integration can leverage. So because the IDE is written, the IntelliSense is written on top of the type checker, you get to extend the type checker in this very controlled way. You get to extend your IDE. So basically, we can scale to a huge schema. You get strong static types, supposing that you wanted them. But the people have said, even the people against types have said that one benefit is that you get IDE support. And really, you can add new data protocols really easily. So like the wizards that are built into Visual Studio are fixed, right? It's very hard to add a new one as an end user. But with a type provider, you can do that really easily. So some examples, web services, SQL, you have your own file format, an XML file, a regular expression. You could name the different parts of the grouped expressions within a regular expression. There's a Facebook type provider that basically lets you you can dot and see a list of people's friends right in IntelliSense, which is kind of cute. So an interesting question is this giving us, is there a new trend in language design now? Basically, this feature was really driven by the tooling. If there weren't that tooling support, to me personally, actually seems pretty unlikely that this feature would have been implemented, because you'd get type checking, but type checking without tool support is not so, it doesn't really cut it anymore. So I actually looked for examples that of the same kind of thing. If do other language designers do this as well? And it seems like so far, actually, this is a pretty rare concept. So usually you think about the IDE after you design the feature, and then maybe you tweak the feature a little bit to make it work well with the IDE, but it's not a primary consideration. But there are some examples of this. So although you can see they're mainly for languages used for teaching, like Dr. Scheme and Racket are mainly used for teaching Scheme, and Alice is a programming language designed for children to learn programming by doing animations. And there, the IDE and the language designs are, basically they co-evolve. You wouldn't add a new feature if it didn't make sense for the IDE. And if you want a new IDE feature, you would definitely change your language. A small example of this is that one motivation for Java annotations is that now that allowed the J2EE tools to work better, because J2EE is pretty complicated. You need tooling. So this is one way to ameliorate that. Partial classes in C# are also, you could think of it sort of as this similar idea, because one of the main benefits are that the UI tools can create code that then gets compiled into the rest of your program. Another example is another programming language for children called Hands. And they actually went back and tweaked the syntax to make sure that they would give good syntax errors. So for here, in this if expression, they actually added an ellipsis, which is actually more things to write, but it meant that when the user, which it was targeted at children, they made a mistake, it would actually help them along a lot more than if they had a more concise syntax. So looking ahead, what's next for F# is basically to align really well with cloud, because right now F# is pretty well suited as a server-side language, but Azure is pretty great, and as are other similar cloud services. And F# has this nice thing with F# computation expressions where you can basically add new syntax, or it looks like you've added new syntax, but you actually can just do it in a library. So maybe you could add a cloud computation expression, similar to how we have the async and query computation expressions that aren't new syntax, they're just libraries. So you can also do computation in the cloud with a cloud numerics library. I'm not going to go into this right now, but it works very nicely with F#. I'm not going to do that demo. So basically, type providers give you an integrated solution for accessing data sources, and you get to stay code focused, right? We're programmers. We don't want to run a wizard. Let the designers run the wizard. We want to stay in the code. And you want your tooltips to be helpful in your IDE, like we learned what a supercouple was from our IDE. And this gives you a really nice, consistent, uniform programming experience. Even if your data sources are all completely different, they use completely different protocols, you don't have to worry about it if the type provider is well designed. And now the schema change integrates with the rest of your programming language, where before it was a separate thing that was kind of glommed on the side, and you had to kind of fiddle with it to make it work. So I encourage you to try out F#. The beta is out. It doesn't have very many bugs yet. We're adding some more right now. So and it works side by side with Visual Studio 2010. So if you happen to use that, you can install, uninstall. I do it on my laptop, which I never want to reformat. So that should work fine. Thank you very much.